These are the answers to homework 4E. Question number 1, write the balanced net ionic equation for each of the following, each of which results in a reaction occurring. Indicate the phase of each reactant and product. Each of these reactions we're going to do today are going to be oxidation-reduction reactions that turn out to be non-obvious. The first one, solutions of potassium dichromate and hydrochloric acid are mixed. If we were to switch the partners, we don't get a precipitate, we don't get water, we don't get a gas. That means go to Plan 9, write the reactants in ionic form. If we recognize one of the reactants as a strong oxidizing agent, then we know it's going to be a non-obvious redox reaction, and we predict the products by calculating the oxidation numbers of all the elements in the equation. Potassium's positive 1, in the dichromate ion chromium's positive 6, oxygen's negative 2, hydrogen's plus 1, chloride's minus 1. The dichromate ion is the strong oxidizing agent, and you need to know what it gets reduced into. It turns into chromium 3, and if chromium 3 is produced, that means that's the reduction. Chromium 6 is going down to chromium 3. You have to find the element whose oxidation number can go up. Potassium can't go up, hydrogen can't go up, but anions of nonmetals can go up from negative to their elemental state, so we're going to produce elemental chlorine gas, Cl2. Now, those are the predicted products. The potassium ions and the hydrogen ions are spectators. To balance the equation, we're going to write the two half reactions. First, the reduction half reaction, the dichromate turning into chromium 3. If we want to, and the second one is going to be the oxidation half reaction, the chloride turning into diatomic chlorine. So to balance these individually, first balance the non-oxygens and hydrogens first. In the top reaction, there's 2 chromiums on the left. We need a 2 on the right. Next, balance oxygens with waters. There's 7 oxygens on the left. We need 7 oxygens on the right. That comes from 7 waters. The 7 waters have now created 14 hydrogens on the right side. So we're going to balance the hydrogens by adding hydrogen ions, and they go on the left side, 14 hydrogen ions. All the elements are balanced. The final step is to balance the charge. The 14 hydrogens make 14 positives. This is a negative 2. So positive 14 and negative 2 add up to positive 12. The 2 chromium ions make positive 6. So if the left side is 12 and the right side is 6, we need to add the negative electrons to the side with the higher charge. And if we added 6 to them, that would equalize the charge on both sides of the equation. For the second half reaction, balance the non-oxygens and hydrogens first. So put a 2 here to balance the chlorines. There are no O's, there are no H's, so that's done. Now we balance the charge. The charge on the left side is negative 2, but the charge on the right side is 0. So we'll put the electrons on the right side, which is the higher charge. 0 is higher than negative 2. And we need 2 of them to make the charges equal to each other. So now that we have our 2 balanced half reactions, before we can add them together, we have to equalize the electrons gained and lost. And because the bottom reaction is only losing 2 electrons, where the top reaction is gaining 6, we're going to multiply the whole bottom reaction by 3. So it'll become 6 chlorides yields 3 Cl2s plus 6 electrons. When we add those together then, the products will now be 6 electrons plus 14 hydrogens plus a dichromate ion plus 6 chlorides yields 2 chromium 3s plus 7 waters plus 3 Cl2s plus 6 electrons. 6 electrons cancel out, and what's left over leaves us the net ionic equation. 14 hydrogen ions aqueous plus dichromate ion aqueous plus 6 chloride ions aqueous yields 2 chromium 3 ions aqueous plus 3 chlorine gas molecules plus 7 water molecules that are liquid. Reaction B, a precipitate of cadmium sulfide is treated with concentrated nitric acid. So cadmium sulfide is a precipitate, nitric acid, HNO3, and when you have concentrated nitric acid as a reactant, we know that's one of our strong oxidizing agents, so we're going to go to Plan 9 and write the reactants in ionic form. The precipitate stays bonded together, but strong acids ionize completely. And to predict the products, we're going to do the oxidation states. Cadmium is underneath zinc on the periodic table. Cadmium and zinc only form positive 2 ions. The cadmium's plus 2, sulfide is negative 2. Hydrogen is plus 1, and in the nitrate ion, the O's are negative 2 each, so the nitrogen has to be positive 5. We know the nitrate component of concentrated nitric acid, when it acts as a strong oxidizing agent, gets reduced to the orange poisonous gas nitrogen dioxide, where the nitrogen's oxidation state is 4. So the nitrogen is going from 5 down to 4. That's the one that's being reduced. We have to find an element whose charge can go up. Cadmium can't go any higher than 2. Hydrogen can't go any higher than 1. But sulfur is an anion, and negative ions can be oxidized up to their elemental state. So we're going to produce elemental sulfur, which is an octaatomic molecule. To balance the reaction, we'll write the two half reactions. First, the nitrate turning into NO2, and then second, the cadmium sulfide turning into S8. Balance the first half reaction. Non-oxygens and hydrogens first, 1N, 1N, that's balanced. Next, oxygens with waters. 3 O's on the left, 2 O's on the right. We need one more O on the right, so one water molecule must be added. That now puts 2 hydrogens on the right, so we need 2 hydrogen ions on the left to balance the hydrogens. All the elements are balanced. Now we'll balance the charge. This is 2 positive 1s and a negative 1. 2 and negative 1 add up to positive 1. The charge on this side is 0 because there's 2 molecules, so we're going to put 1 electron over here on the left side. For the second reaction, balance all non-oxygens and hydrogens first. So we have to balance the sulfurs by putting an 8 here, and then that gives us 8 cadmiums on the left side, and there aren't any cadmiums on the right, so we're just going to have to add them to the right side, but we have to keep them in their same oxidation state. In this ionic compound, cadmium ions are positive 2, so when the sulfides rather, turn into sulfur and they disappear, those 8 cadmium positive 2 ions will just float off, and so you just write 8 cadmium positive 2 ions on the product side. In terms of charge, the left side is only a neutral molecule, that's 0. The right side has a neutral molecule, and then it has 8 times 2, or positive 16 as its charge. So 0, positive 16, we need to put 16 negative electrons on the right side, and now the charge is balanced for the second reaction. To add them together, we're going to have to multiply the entire first reaction by 16. That will give us 16 electrons, 32 hydrogen ions, 16 nitrates, 16 nitrogen dioxides, and 16 waters. So when we add them together, the reactant side will be 16 electrons, 32 hydrogen ions, 16 nitrate ions, and 8 cadmium-2 sulfides. The product side will be 16 nitrogen dioxide, 16 waters, an S8 molecule, 8 cadmium-2 ions, and 16 electrons. The 16 electrons cancel out, and the final reaction is 32 H plus aqueous plus 16 NO3 minus aqueous plus 8 CDS solid yields 16 NO2 gas plus 16 H2O liquid plus S8 solid plus 8 CD2 plus aqueous. C. An acidified solution of potassium permanganate is added to a solution of sodium nitrite. So here's our reactants, 2 compounds. If you switch the partners, they don't produce water or a precipitate or a gas. So this must be a non-obvious reaction. And because the first reactant contains the permanganate ion, this is going to be a non-obvious oxidation reduction reaction. Plan 9, write the reactants in ionic form. The first compound dissociates into a potassium ion and a nitrate ion in solution. The second one dissociates into a sodium ion and a nitrite ion in solution. The oxidation numbers, potassium's +1. In permanganate, manganese is 7, oxygen is -2. The sodium ion is +1. And in the nitrite ion, O is -2, so the nitrogen has to be +3. So when you add it to the -4 of the 2 O's, it gives you the total charge of -1. So if this is an acidic solution, permanganate as an oxidizing agent gets reduced to manganese 2. So the manganese is going from 7 down to 2. You have to find an element whose charge can go up. Potassium can't be higher than +1. Sodium can't be higher than +1, but nitrogen has 5 valence electrons. It could be as high as +5. And the way it's going to turn into a +5 ion is by having a nitrite ion change into a nitrate ion, NO3 minus. The 2 half reactions, first the reduction is MnO4 minus yields Mn2 plus. The oxidation is NO2 minus goes to NO3 minus. Balancing the half reactions. First, balance all non-oxygens and hydrogens first in the top one, 1 manganese, that's done. To balance the oxygens, add water molecules. We have 4 oxygens on the left, so we need 4 oxygens on the right. That means we're going to add 4 water molecules. That gives you 8 hydrogens on the right side, so we'll add 8 hydrogen ions to the left to balance the hydrogens. Last step is to balance the charge. This is 8 positive ones and a negative one. 8 and negative 1 makes 7. The charge on the reactant side is 7. The charge on the product side is only 2. That's a difference of 5. So 5 electrons have to go onto the reactant side to balance the charge. Second half reaction. Balance the non-oxygens and hydrogens first. 1N, 1N, that's balanced. Next, balance the O's with waters. We need 1 more O on the left side, which means you add 1 water. Next, balance the hydrogens with hydrogen ions. We have 2 hydrogens on the left, so we need to put 2 hydrogen ions on the right. Now balance the charge with electrons. Neutral molecule, -1 ion. This whole side is -1. -1, +2. This whole side is +1. -1 and +1 have a difference of 2, and we're going to put the 2 electrons on the higher charge side, and now the charge is balanced on the left and the right. To add these 2 half reactions together, we need to get the electrons to be equal to each other, so we'll need a common multiple between 5 and 2, which will be 10. So I'll multiply the whole top reaction by 2. It'll become 10 electrons, 16 hydrogen ions, 2 permanganates, yield 2 Mn2 plus 8 waters. And the whole second reaction has to be multiplied by 5. So 5 waters plus 5 nitrites yields 5 nitrates plus 10 hydrogen ions plus 10 electrons. And if we add them together, these would be the reactants, and these would be the products, just combining them together. Once we've done that, we have the 10 electrons on both the left and the right side, which can be canceled out. And in this case, we actually have some other common things as well. We have 16 hydrogens on the left, and we have 10 hydrogens on the right. So I'm going to cancel out 10 hydrogens here and 10 hydrogens here, leaving 6 hydrogens on the left. I have 5 waters on the left, 8 waters on the right. I'm going to cancel out 5 waters from both sides. It's going to leave 3 waters on the product side, and this is our final equation. Only 6 hydrogen ions aqueous left over, plus 2 permanganates aqueous, plus 5 nitrites aqueous, yields 2 manganese 2 ions aqueous, plus 5 nitrates aqueous, and then only 3 water molecules of liquid left over. D, a basic solution of potassium permanganate is added to a solution of lead 2 nitrate. So in this case, the 2 compounds, if we switch their partners, we don't get a precipitate, we don't get water, we don't get a gas, must be a non-obvious reaction. So go to Plan 9, write the reactants in ionic form. Each of these are soluble compounds, so they would dissociate into their constituent ions. Because the permanganate ion is one of the reactants, we know this is a non-obvious oxidation reduction reaction, so we're going to write down the oxidation numbers to try to predict the products. Potassium is +1. In permanganate, manganese is +7, O is -2, lead 2 is +2, and in the nitrate ion, the nitrogen is 5, the oxygen is -2. This was a basic solution, and in basic solutions, permanganate gets reduced to the precipitate MnO2 solid, where the manganese has a +4 charge. So the manganese has gone from 7 down to 4. It's been reduced. We have to find an element that can go up. Potassium can't be any higher than +1. Nitrogen can't be any higher than +5, but lead has 4 valence electrons, so the lead ion can be oxidized up to +4. That's our other product. So the 2 half reactions are the permanganate ion going to MnO2 and the lead 2 ion going to lead 4. And because this was a basic solution, before you go any further, you have to think about, okay, did I produce anything that could precipitate with hydroxides? And if you produce a cation as a product, from the solubility rules, will lead ions precipitate with hydroxide ions? And the answer is yes. Hydroxides precipitate with every cation on the periodic table except for the alkali metal ions and ammonium. So therefore, we need to change that to Pb, OH taken 4 times. That's a precipitate. So we're actually forming 2 precipitates in this particular reaction. So let's balance the half reactions. The first one, non-oxygens and hydrogens, 1 manganese, that's done. Balance the oxygens with waters. We have 4 oxygens on the left, 2 of them already on the right. We only need 2 more on the right, so I'm going to add 2 waters. That gives me 4 hydrogens on the right side. So we're going to put 4 hydrogen ions on the left, and now all the elements are balanced. The charge now, 4 positive 1s make positive 4, and that's a negative 1. So 4 and negative 1 make positive 3. These are 2 neutral compounds, that's 0. So positive 3 and 0, we'll need 3 more negative electrons on the left side to balance the charge. For our second half reaction, balance all the non-oxygens and hydrogens first. 1 lead, that's balanced. Balance the O's with waters. We have 4 O's on the right side, so I'm going to need 4 water molecules on the left. And now with the hydrogens, we have them on both sides. There's 8 hydrogens here. There's 4 hydrogens here. I need 4 more hydrogens on the right side, so 4 H pluses. For the charge, this side has only a positive 2 ion. This has 4 positive 1s. So positive 2, positive 4, the difference is 2. I need 2 electrons on the right side of my second reaction. For me to add these together, I need to make the electron changes equal. And in order to get 3 and 2 to be equal, we'll need to get a common multiple of 6. So I'm going to multiply this reaction by 2, which will give me 6 electrons, 8 hydrogen ions, 2 permanganates, 2 manganese 4 oxides, and 4 waters. And the second half reaction will be multiplied by 3, so I'm going to have 12 waters, 3 lead 2s, 3 lead 4 hydroxides, 12 hydrogen ions, and 6 electrons. So if we add them together, the reactants are 6 electrons plus 8 H positives plus 2 MnO4 minus plus 12 H2O plus 3 Pb2 plus. Product side is 2 MnO2 plus 4 H2O plus 3 PbOH taken 4 times plus 12 H plus 6 electrons. 6 electrons cancel out, and then we're going to simplify. There's 8 hydrogens here on the left and 12 hydrogens on the right. So I'm going to cancel out all 8 hydrogens on the left, and it's going to leave 4 hydrogens left on the right. I have 4 water molecules here on the right, and I have 12 water molecules on the left. So I'm going to cancel out all 4 on the right and subtract 4 and get 8 water molecules left over on the left side. So this becomes 2 permanganates down to 8 waters, 3 lead 2s, yields 2 manganese 4 oxides, plus 3 lead 4 hydroxides, plus 4 hydrogen ions. And this would be the end if it was an acidic solution. But they said the solution's basic, so you cannot have hydrogen ions in a basic chemical reaction. So we've got to switch these hydrogen ions into hydroxides, and we do that by adding this number 4 hydroxides to both the left and the right side of the equation. And the reason we do that is we add the same number so it stays balanced, but this actually causes 4 hydrogens and 4 hydroxides to turn into 4 waters. So on the right side, we're going to wind up getting 4 waters, and then the 4 waters I've created here on the right side, these 4 waters, will cancel out with 4 of the waters on this side, reducing down to 4 waters on the right, on the left, and no waters on the right. So our final equation becomes 4 hydroxides aqueous plus 2 permanganate ions aqueous plus 4 water molecules liquid plus 3 lead 2 ions aqueous yields 2 manganese 4 oxide solid plus 3 lead 4 hydroxide solid. The final one, E, acidic solutions of hydrogen peroxide and sodium oxalate are mixed. When you see hydrogen peroxide as a reactant, this is going to be an oxidation reduction reaction. So I'm going to go to plan 9, write the reactants in ionic form. You could have switched the partners. There's no precipitate, no water form, so it has to be a non-obvious reaction. Hydrogen peroxide with plan 9 written in ionic form because it's not a strong acid, not an ionic compound. It stays bonded together. But sodium oxalate is an ionic compound. When that dissolves in water, it does dissociate into ions. The oxidation numbers for this, hydrogens are +1 each. That means the O's have to be -1. A peroxide ion is a rare example of a compound where oxygen does not have its natural -2 oxidation state. Each of the O's are -1. Sodium is +1. In the oxalate ion, the O's are -2 each. There's 4 of them. They add up to -8. So the carbons must add up to +6. And because there's 2 carbons, each carbon must be +3. So in this reaction, the hydrogen peroxide gets reduced into water because the oxygen in the peroxide is going from -1 down to -2. That's the reduction. You have to find an element that can go up. Hydrogen can't go up, sodium can't go up, but carbon has 4 valence electrons. It could go up to +4, and the most likely way you're going to get a carbon in a +4 oxidation state is as the gas CO2. So this would be the other product. The half reactions are hydrogen peroxide turning into water, and then oxalate ion turning into carbon dioxide. Let's balance them. In the first one, balance all non-oxygens and hydrogens first, so don't have to do that. Next, balance the O's by adding waters. So I need one more O on the right side, so I'm going to add one more water by just putting a 2 there. That now makes 4 hydrogens on the right, but I only have 2 hydrogens on the left, so I need 2 more hydrogens on the left, so +2. And then because the charge of the left side is now +2 and the right side is 0, I need 2 electrons to balance the charge. That's our first half reaction. Second half reaction, balance the non-oxygens and hydrogens first. There's 2 carbons on the left, only 1 on the right, so you have to put a 2 here to balance those carbons. Now, balance the oxygens with waters. There's 4 oxygens on the left, and there's 4 oxygens on the right, so they're balanced, don't add any waters. And balance hydrogens with hydrogen ions, but there aren't any, so I don't have to do that. So that's done. Last step, balance the charge. The left side is a -2 ion, and the right side is neutral molecule, so at 0, I need to add 2 negative electrons to the right side to make the charge equal to -2 on both the left and the right. And here in our last one, how fortuitous, the number of electrons gained and lost are exactly equal, so I can just add these together. I'm going to get 2 electrons plus 2 hydrogen ions plus a hydrogen peroxide molecule plus an oxalate ion yields 2 water molecules plus 2 carbon dioxides plus 2 electrons, and the electrons cancel out, and that's going to give you your final net ionic equation, 2H plus aqueous plus H2O2 aqueous plus C2O42 minus aqueous yields 2H2O liquid plus 2 CO2 gas.